I now would like to introduce our second panel of the day on AI for communities and organizations. Please welcome our speakers to the stage. We have Niloufar Salehi, Melissa Valentine, and Michael Bernstein. Niloufar is an assistant professor in the School of Information at the University of California, Berkeley. And I also would like to say we are proud of her as a PhD alum of our own department. She's a superstar. Melissa is an associate professor of management science and engineering, as well as the co-director of the Science of Work, Technology, and Organization here at Stanford. She also did her undergraduate degree here too, so. And then Michael is an associate professor of computer science and the STMicroelectronics faculty scholar here at Stanford, also a bachelor's degree holder from Stanford in the fabled symbolic systems program. And I also like to say my personal mentor, so thank you, Michael, for being here. Unfortunately, Christina Harrington was unable to travel today, and we look forward to hosting her at a future event. But we'll have the same format that we had earlier. We'll have each of the panelists speak, and then we'll have a discussion. So first we'll have Niloufar.
Thank you so much, James. It's exciting to be back here at Stanford. So before I start, I just wanted to take a moment to say that all of the work that I'm going to present here today was done by graduate students at UC Berkeley, and some of you might have heard that there is an ongoing strike. It's the biggest strike since 2019 by any worker group in the US. So I just wanted to acknowledge that and say that I think that a lot of the ways that our institutions treat our graduate student workers and postdocs are unfair, and especially when you have students who are rent burdened and are facing food insecurity, I think it's frankly inhumane. And so in the last panel, I really liked how the conversation ended on how do we sort of build the worlds that we want to live in, and seeing these students and the work that they're doing really gives me hope that we are working towards those futures that we want to live in. And so with that, I'm going to start talking about human-centered machine translation for high-stakes situations. And I'm going to start with sort of a situation. Imagine that you're a physician and you want to tell a patient who's come to you that they should hold the kidney medicine until they've had a chance to speak to their kidney doctor. The problem is that you speak English and your patient only speaks Mandarin. So you put what you were just about to say to the patient into Google Translate, and you get this back. Now, I'm assuming that a lot of the people in this room don't speak Mandarin, and so I wanted to do a show of hands. How many of you would send this off to the patient or show it to the patient?
Google Translate, yeah.
All right. And how many would not do that under any circumstances? All right, thank you. I'll talk more about this, but actually in the real world, people do share it a lot. But the problem is that what this has actually been translated to is the opposite of what the physician wanted to say. It's keep taking your kidney medicine until you've talked to your kidney doctor. And so as an HCI scholar, we look at this interaction and we see two big problems, right? The first is that in this interaction, it's hard or in many cases impossible to identify errors. And the other problem is that even if we did identify the error somehow, we wouldn't have any actionable strategies to recover from the error. And so starting off from this example, what I'm going to talk about today is what HCI methods can teach us about how we can design and use these AI systems like machine translation that is widely adopted. And I'm going to talk about two main phases of HCI that HCI people in the audience will be familiar with: needs assessment and then design and development. And I'll end with some open questions that we still have. So the first thing we did in this project is often known as needs assessment. We started looking at what are conditions where machine translation, what are conditions that we could potentially test this? And one of the things that we found early on was that discharge instructions actually have really high impact. There was a study that was done actually by some of our collaborators at UCSF Hospital where they found that for patients who have low English proficiency, they score worse on almost every post-discharge scale that they could look at. So things like following through on medication, coming back if any of the conditions that they were supposed to come back with happened. So we know that these text documents that people are usually sent home with, discharge instructions, are text-based. They seem like a good place to intervene, and they're almost always given to people in English. And so we started thinking that machine translation in this condition has the potential to massively improve these communication barriers that people have across language barriers. But one big problem is that it doesn't always work, and that errors can have really high-stake consequences. So there have been a number of studies. One that was actually done by some of our collaborators at UCSF Hospital found that 8% of the common sentences that would show up in medical discharge instructions from an emergency room were incorrectly translated by using Google Translate from English to Chinese in a way that they carried potentially critical and significant harm. So if you just look at which ones are incorrectly translated, it was something around 20% of commonly used things that people say in emergency discharge instructions. But 8% of those were, and the example I showed at the very beginning was an example of one of those sentences that was actually said to a patient, carried significant harm. Another study showed that 17.5% of translations of emergency discharge instructions across 7 languages did not retain the meaning. And it's worse for low-resource languages and languages that are further from English. So for Farsi, it was something like 32%, and for Armenian, it was 45%. And this has led to a lot of articles in popular press talking about how Google Translate still isn't good enough for medical instructions. So what HCI teaches us in this kind of a situation is to start asking, what are the user needs for machine translation in this sort of a medical setting, for medical communication, and how can we design for them? And so the HCI methods that we usually use for a needs and values assessment, one is to do what's commonly known as need finding, so decentering the technology, centering the people, their organizations, their activities, and starting to ask, what did they do? Why did they do it? But I'm going to argue that that's not going to be enough, really, for AI systems, because there's this whole other set of things that we need to know, and are ways that I think needs assessment needs to be expanded. So you can't really do needs assessment independent of knowing how the system works. A major component of these AI systems are the modeling assumptions that they make, some constraints that we know exist in the context that they're used. So these kinds of things, I think, are actually really important. And so it's not that you could do need finding independently. I guess you could sometimes, but a lot of the times, they sort of have to happen iteratively and in parallel. So algorithm design is happening at the same time as we're trying to better understand the context of use, the needs, and the values. So I'll quickly go over 2 things that we've done here. The first one, trying to take the first method, and the second one, trying to better understand the data and the modeling assumptions. So the first was a very classical HCI interview study that we did. We conducted semi-structured interviews with 20 healthcare clinicians across 7 specialties, and we tried to understand how they're using machine translations in a medical setting. We spoke a lot to people who worked in conditions where they had a lot of low English proficiency patients, and this was published in FACT this year. Some of the things that we found were pretty expected, like they had limited time and resources, which meant that almost everyone that we spoke to was actually using Google Translate in the hospital, which is surprising given that a lot of you said you wouldn't. There was also a lot of cultural barriers, issues with medical literacy that were separate from just knowing English. And another thing that we found that I thought was really interesting was their emphasis on accuracy and accountability. And especially for physicians where errors can be life-threatening and then there's all these liability issues, they cared a lot about the accuracy and accountability part. Another thing that we looked at, which I thought was really fascinating, was the strategies that they were currently using for this communication. So I think that oftentimes, and even in HCI, when we think of communication between people, we think of it as this one-way transfer of information. But the way that the clinicians that we spoke to thought about communication was more of a mutual production of meaning kind of way. And part of that, for instance, includes testing someone's understanding, so testing to know whether they understood what you said or not. So the clinicians who we spoke to, in addition to using the Google Translate often on their phone, were also using social cues. They were using what's known as teach-back methods, where you say something to the patient and then have them repeat it back to you. They asked patients to repeat information. They also use mental heuristics, and they used a lot of nonverbal communication as well. So one example was someone that would draw a picture of a person and show it to the patient and say, could you point to the parts that hurt? So I thought that was really fascinating. And thinking through that, we've sort of been thinking about the social role that an interpreter plays in these kinds of situations as a guide towards design. And there's been a ton of work on what interpreting is. So an interpreter is someone who comes with you and knows both languages and translates, basically. And they do a lot more than converting the text to the other language. In fact, there's been a lot of work on these different metaphors of communication that I mentioned. The monological model being, language is seen in a social vacuum. It's like, I have a message, I transport it to you, versus a dialogical model, which thinks of communication as a joint production of meaning. And so sense is made by a common activity, and there's reciprocity in communication, and especially in miscommunication, like in cases where there are errors. And so thinking about these two metaphors of communication, I wanted to show you what our translation interfaces have looked like for the past 10, 20 years. And to start thinking about which metaphors of communication are baked into this interface. So we'll come back to that. But the other part of our needs assessment was looking at verifying system constraints and data and modeling assumptions. We got a data set of over 3,000 discharge instructions from our collaborators at UCSF Hospital. And some of the things that we found was almost all of it was in English. It was often not translated, but it was also really structured and repetitive. And so this is really important if you're thinking about building an AI model, if you know these facts about what the data actually looks like. So the next thing I'm going to talk about is what we've actually done with this data and with this project. So like I said, our clinician strategies, we found that a lot of what they were doing was basically this dialogical model of communication, so using teach-back methods, back translation, nonverbal communication. And that they cared a lot about seeking verification and a pragmatic approach. And so given that we have these discharge instructions, and we know that it's really, really, really repetitive and really structured, you can start to think, what if we had a memory of all the translations of the common things that are said? And then if you do have that, then the problem that we had earlier, which was I have this text in English, I do not know Mandarin, and I want some way to verify that the thing actually says what I want it to think, can be changed from a translation or a black box translation model to a retrieval model. So what if I had a memory of a lot of the things that I think you might want to say, and then I just matched your intent. So I said, OK, when you say hold the kidney medicine, I think what you're trying to say is do not start taking your kidney medicine. And then I actually know how to translate this because it's in my translation memory. And so you can verify that this is actually what I wanted to say. And you can start thinking about this larger model as an alternative way to think about different inputs, especially in problems where there's a small set of potential inputs and people can verify their intent with the input, and we can sort of verify the output as well. So you can start thinking about in visualization scenarios, or maybe even in diagnostic scenarios, how you might be able to use this. So my students have been building this translation memory for the emergency discharge instructions. It has some basic ideas like taking out the words that are words of medicines or things like that and replacing them with sentence structures and trying to clustering them and finding things that we think will probably have the same kind of meaning. And we've been thinking about how would you actually use this. So here's a very, very short demo of a tool that, as a physician, is writing out the discharge instructions, is actually pulling from the memory to suggest things that they might actually be wanting to say. And if you have this, then you have much more than an ability to verify translations, but you also have a really structured way of keeping the data as well that you could use later. So I'll wrap up with some open questions that we still have. A lot of these are in this workshop paper that we presented at the HCI plus machine translation workshop at EACL. Some open questions in NLP are, a lot of the times one thing that you can quickly verify is whether something is even a good candidate for translation. So how can you automatically identify that? And then if you did, how do you help people understand that and repair? So here's an example of a Slack bot that, given something that is hard to translate, will offer you suggestions of other things that you might be saying that mean the same thing that are much easier for it to translate. And then thinking through this joint construction of meaning, a lot of overlap with some of the rest of the themes of the conference today, but thinking about how do you, how do you think about quality estimation? How do you make it so that it's more aligned with what people actually need? How do you think about question and answering methods in this joint construction of meaning? And some open questions in HCI can be, how can you think about nonverbal communication as well? So can you think about generating images as a way to help? Or what kind of questions might someone ask a translation system? And one last takeaway is that in all of this work, I think these HCI methods are really, really important, but also need to be further developed for these kinds of settings. And I would really like to thank the students who've led the work and all of our various collaborators at different stages of this project.
Great. Thanks, Niloufar. Okay, now we have Melissa.
All right, good afternoon. My name is Melissa Valentine. I'm a professor in management science here at Stanford. I study how technology changes work and organizations. Today, I'm going to tell you about a study that I did and explain how it shows how AI is changing the nature of human expertise. And I think this question of human expertise is really fundamental to thinking about human-centered AI. So as you know, prediction algorithms, optimization algorithms, machine learning algorithms, these are being configured to do judgments or decisions that typically we've thought of as knowledge work, or things that experts use their critical thinking, like judgments or decisions that experts use their critical thinking to do. So as I've been doing studies in this area, trying to understand how this technology is changing human expertise, I've noticed these two sort of disconnected predictions about what AI is going to do to human expertise. So on one hand, in my home discipline of organizational theory, which is a subfield of sociology, this is a literature review looking at lots of studies in this area. And the conclusion, sort of the sum up of this literature review, is that learning algorithms will lead to the devaluing of knowledge workers' expertise. I also spend a lot of time reading the practitioner literature for data scientists. And this second lit review is from a summary of a lot of different studies of machine learning in healthcare. And you can see that one of the conclusions from this study is that knowledge workers' expertise is becoming increasingly valuable. It's increasingly valuable. So we have one prediction that's predicting a devaluing of expertise, and one prediction that's sort of looking at the devaluing, or it becoming more valuable. So I think that these predictions are less incompatible and less contradictory than it looks on the surface. But I think it's worth figuring out what assumptions are sort of underlying this and how these are connected. So I think one idea that helps us understand these sort of competing predictions is understanding, I think we need to think deeply about what is the nature of knowledge workers' expertise right now. What does it mean to be an expert lawyer? What does it mean to be an expert marketer? What is the nature of that expertise, and how does AI actually implicate that expertise? So in the sociology of work, we have a literature stream that's decades old where people have looked at this. What is the nature of occupational expertise? And there's two themes in this literature that I'm going to pull out, because these are what changed during my study. So one is that occupational expertise is sort of produced, trained, evaluated, reproduced in communities of practice. So if you are an academic, think of how professors learn how to be professors, how grad students learn how to be grad students. It's in a community where people teach each other. It's very relational and interactive. The second piece is that oftentimes communities of practice, especially knowledge workers, will rely on informal theories that help them make decisions. So if I'm a marketer and I'm thinking what's going to be a successful ad, oftentimes I'll be looking to an informal theory of marketing. Like, what do I think makes a good marketer? What makes a good ad? So those are the informal theories. That's the nature of knowledge workers' expertise right now. So the study that I did, I did an ethnography. I embedded at a tech company. The way that I sampled for this company, this actually came after I was doing a study with Michael, who will speak next, and we were discovering how hard it is to get big data, to get enough data to draw insights. So I wanted to give myself a treat. So I decided that I was going to find a company that had all the data and all the data scientists, no silos, using words like data highways and things like that. So I found a company in San Francisco. They let me come study them. So I spent 10 months working at their company, studying their practices. And what I really wanted to do was to look at the specific work practices of a group of knowledge workers before, during, and after an algorithm was developed for them. So the second thing that this study this method, what this offers, is a chance to look not just at the pieces that get automated, because I think that's something that labor economists are able to tell us, but to tell us how that is affecting the rest of the job. What expertise do you have to develop to be able to use an AI system, for example? So these are the things that I think are not yet in the conversation, but need to be included in the conversation. So let me tell you about our knowledge workers, and let me tell you about our algorithm that we're talking about today. So the knowledge workers that I ended up studying just by chance, this is just where all the data and all the data scientists lived, were fashion buyers. So the fashion buyer's job was to stock the inventory for the company. They had to pick the clothes, they had to pick the depth of styles and the breadth of styles that they thought would make a good inventory for this company. And what I'm going to show you through some data is that these decisions were based on informal theories. They really thought of themselves as like making bets on what was going to be a good inventory. So the data scientists who did very good human-centered design for this AI, that's not what I'm going to focus on here, but it's fun and it's in the paper. I think they did a great job of doing the kinds of things that have been talked about during this conference. This is a stylized UI. This is what they had created. So the data scientists made an inventory algorithm that basically was configured to recommend what the best performing inventory would be. So if you want your inventory to have like really good revenue, for example, then you would say, maximize revenue, or recommend 20,000 units of clothes that will give me the best revenue. And then it would generate a list of what are the 20,000 styles that you should buy. So for math lovers, I'm going to give you a test here. I'm not going to ask for the answer, but just so you're just tracking if you're understanding what I'm describing with the algorithm. So let's say that the algorithm is saying, is telling you buy 20,000 units of some clothes, and it's set to maximize revenue. And let's say that I tell you that the jeans that have the highest revenue are the top ones. So what is the algorithm going to tell you? Naively, just like what is the recommendation going to be? If you're thinking it's just going to say buy 20,000 units of the top performers to maximize revenue, that's exactly right. That's exactly what the algorithm is set up to do. So now you understand the algorithm. But they also had an area where the fashion buyers could input their constraints. They would say, you know what, you're telling me buy 20,000 of the blue jeans, but I feel like red is going to be hot. So notice that's my informal theory. I'm like, I think red is going to be the hotter performing style. So you could constrain the algorithm and require it to recommend 10% red. Okay, so how did this change the knowledge workers' expertise? What I'm going to show you, so this is, in my field, this is called a process diagram. This is just event, event, event. So I'm going to focus here first on telling you about the first event, which is just how the buyers started out with informal theories about inventory planning. Then I'm going to describe how the data scientists introduced their expertise, which was in modeling, computation, user interface. And then together, these two groups came up with a new expertise. And basically what they learned how to do was together they learned how to test the buyers' informal theories about a good inventory. So over time, the buyers got much better at sort of registering what their theories were, formalizing it with variables and relationships, and then testing it and sort of entering a feedback loop like that. So first, let me characterize the informal nature of their theories to start with. So I'm presenting just explanatory quotes, but these are examples over the 10 months of things that I saw basically every day. So what I'm illustrating here is the spreadsheets that they use. This was before they had the algorithmic UI. So they use these spreadsheets, and what I've chosen some quotes here that illustrate the nature of the bets that they were making. So one of the buyers is saying, okay, so our vision here is growth. She, the customer, liked these jeans. Does she want them again? We think so. We're giving 1.3 success rate on the upside to say, account for these initiatives, they're coming. We don't quite know what they'll do, but let's prepare, right? So it's kind of a bet. And this is illustrating a community of practice. So they're talking to each other. They're sort of testing each other's like theories. Do you think that this is going to work? I feel like it's kind of balanced, but it's very intuitive. It's very informal. And the most important part of this that I want you to see is that this is an open feedback system. So I would say, I think red denim is going to be really hot this quarter, and I buy a bunch of red denim. And then I'm not actually ever held to account. No one ever asked me, like, how did your strategy turn out? How did your informal theory turn out? Did red turn out hot? It turns out they didn't have a practice for measuring whether their actions had produced the results that they were looking for. So this top quote is in their hindsight meetings, and this illustrates that it was very data-driven. This company was very data-driven. So the buyers are, she's sort of summarizing, she's saying, okay, it's the usual set of metrics. You can check them out if you're interested. Now I'm gonna go into the surprising results. And they would sort of pick different stories from their overall performance. But it was not a, I had said red, here's the test of red. So it is a very kind of open feedback system. So then they started working with the data scientists as partners. They had a very kind of equal relationship in this regard. They worked together to basically co-produce a new expertise. Now what I'm going to illustrate here is a difference in how the data scientists were pushing the fashion buyers to think about their work. And I think what you'll see here, it sounds a little bit it sounds a little bit like empirical science, any empirical science, where you're basically like being asked to like pre-register a hypothesis and then consider the evidence about how your hypothesis did. So here a data scientist is watching a buyer use the interface. The data scientist is listening to the buyer be surprised about the recommendation of 10,000 units of this one style. So the buyer's explaining, okay, so it's putting 10,000 units into this style. And the data scientist started to explain, well, that's what you're expecting. Like you told it to give you, like to maximize revenue. So it's gonna tell you to buy 10,000 of the like most revenue driving style. So the part that I sort of highlighted in purple here, so it says, this is where you get to be creative. This is where you get to pick out the breadth that you want. So they started pushing the buyers to, in advance, like at the start of the quarter, sort of go on record and be like, I'm registering this strategy. I'm going all in on red. So it's articulated up front. It was not like that before. The second one is they started to push them to identify the evidence that they would need to reject their hypothesis. So they thought 10,000, the buyers thought 10,000 units was too many units. So they started being asked, well, what evidence would make you make that bet? Like, what would you need to know to want to go 10,000 deep into this style? And they started to ask them to think like that and to articulate evidence to reject their hypothesis. Lastly, this was strategic thinking, so they also were pushing them to kind of articulate trade-offs that they would be willing to make. So let's say that they decided to go all in on red denim and they recognized that that was risky, then the data scientists would basically push them to say, like, how much of an upside would you need to be expecting to take a risk like this? And they taught them to sort of explicitly narrate the trade-offs in that regard. Okay, so the final piece, this is the part that I think is revealing kind of a new expertise and a new way that I think that data scientists and knowledge workers are going to work together. So this is a new expertise. I have evidence, I'm going to show you evidence that the fashion buyers by the end of the study had changed their practice and they had become much more formalized in the way that they tested their own theories. And in some ways, we expect that knowledge workers are supposed to be disempowered by this, but actually they were able to go push back on the data scientists and say, like, your algorithm is not performing. Your predictions are off, for example, because they'd sort of learned this like practice of measurement. So here is an example where the data scientists were having office hours. This was after the algorithm had been in use, and they actually had the actualized business results. So the buyers had followed the recommendations, they had their results back. And they brought back to the data scientists, they themselves had like made a spreadsheet. They looked at all the predictions that the algorithm had made and calculated how many times the algorithm had been off. So they brought that evidence to the data scientists as kind of formal theory testers themselves. The last piece that I'm going to emphasize is they really had started to understand themselves differently. They thought of themselves now as testing their theories. So here's some language in their quote. They also talked about themselves as kind of double checking. They were double checking their theories. They were using the algorithm to really kind of double check their intuition. So in summary, this study shows a new expertise, a co-produced expertise. You needed both data scientists, you needed both the knowledge workers to work together to develop this. And it gave them a new expertise in being able to kind of test their informal theories with these closed feedback loops. So to conclude, algorithms lead to a devaluation because it taught the knowledge workers to falsify their own theories. So it devalued because now they're falsifying their intuition, but in ways that they could measure, which was empowering for them. And then it's invaluable because it needed to be baked in, basically designed into the way that the algorithm was working. Thank you.
Great.
All right. So let's dive in. We don't all agree. We've talked about a lot of things today. I want to zoom in on one place in which we don't all agree, but that has a lot of impact. let's talk about ground truth. This is the data that we use to power and train all of these algorithms we've been describing. Now, I'm a social computing designer, so I'm interested in the creation of technologies that bring people together, connect people online. And in my travels in social computing, we see AI algorithms being embedded in all sorts of online social environments, ranging from AI tools that are used to identify comments that are toxic and should be pulled down from a social network, finding misinformation, moderation decisions, and so on. So if you've never seen one of these kinds of algorithms, here's one of them. This is one that Google made, where you feed it text, might look something like this, and it's going to make some sort of decision, a recommendation, here thinking that this particular comment, despite its obvious veracity, is 95% likely to be toxic. Okay, but now what? Should this comment, this one that's taken from a large data set that's used to train these algorithms, be classified as toxic or not? Now, if I were to take a survey of us here, and it were representative of the kinds of folks that tend to answer these, it's actually kind of a split jury. It's 50-50. About half of people think that this crosses the line. The other half would argue that it wouldn't. But who's answering which way? That matters. But it's kind of elided and invisible, kind of implicit in the architectures that we use to build AI systems today. That we typically, what we'll do, having traveled in sort of the data annotation world for a while, is we go out, we ask a number of people what the right ground truth answer to this thing ought to be, and then we do something like aggregating their answers. Say 3 people here said gray, 2 people here said red. We just take a majority vote, and we say, all right, well, most of the people said this is gray, so we're going to assign this the ground truth label gray. Okay, well, we then do this across a whole bunch of data items, use that, feed it to your neural network, train. Okay. For many years, this has worked pretty well, but it's starting to show its seams. And in fact, I would argue it's much more than just starting to show its seams. Now, in a traditional machine learning task, something that's using largely maybe what you'd think of as sort of perceptual or low-level cognitive aspects of our brains, something like, is this a dog? Hopefully, we're all going to agree on the right answer to this. This makes the sort of aggregation a fairly safe maneuver. But in social computing tasks, increasingly, like toxicity detection, if it's 50-50, what are we going to do? Unfortunately, when we aggregate, this is silencing minoritized groups, right? When the disagreement is irreconcilable, who we sample for the labels matter. And unfortunately, those who are often subjected to, say, harassment online in this case, are easily going to be overridden by majority vote because you take the majority vote, and unfortunately, they're just fewer in number, and this thing is going to get labeled non-toxic. I just want to convey to you how widespread this kind of disagreement is. In fact, in a large data set, if you just take the things that are labeled as toxic and you bootstrap, resample the data set, and you say, all right, let's see how stable this is, about 40% of the labels flip. The actual training labels flip just by resampling from the same data set. Expert Reddit moderators, I think it's number 10 website, though who knows, with Twitter, maybe it's going up, disagree with each other on about 1/3 of posts and whether it crosses the line and ought to be removed. In one large social network had a bug in their system for a while where they were feeding their fact checkers the same link twice without realizing it. Turns out that fact checker was disagreeing with themselves 1/3 of the time. And this is not just in social networks. When we're looking at medicine, which expertise has the ability to, or has the power to make these kinds of decisions? If you're a designer, for example, the kinds of design advice you'd want to get if you're in one area of design are going to be very different than the kinds of design advice that might conflict with that if you're a different kind of designer. And yet we see things like this, where you have this data set and you have these ROC AUC scores that are like, yeah, we're perfect at this. And I think this belies a kind of two cultures problem, where traditionally in AI, we have something where we're trying to evaluate technical performance and measure generalization error. And in HCI, we're sort of often looking for user-facing experience. We're measuring attitudinal responses and so on. And these are fairly correlated with each other when there's not disagreement, right? You're going to say 100% accuracy and probably all of the users approve. But in the case where we disagree, you might still say 100% accuracy because of this majority vote. But no HCI person worth their salt is ever going to say 100% of users approve, and they might not even launch this thing. So in some work that was led by students in my group, we're starting to see that this kind of number, like 0.95 ROC AUC, is really inflated. You can start to look at this and say, well, what percentage of users who actually see this thing will agree? Gives a very, very different kind of answer, right? A much less convincing measure. And my argument would be that we will make different kinds of product decisions, as Salima was orienting herself toward earlier today, if we align our metrics with the things that matter. So the metrics matter, but also the models matter. So what I'd like to do is sort of offer another possible alternative we could examine, something that we call jury learning. Rather than simply hiding this sort of implicit jury of who's deciding what the right answer ought to be, can we make it explicit? When you create the model, can we ask the practitioner or the researcher to specify a jury of, say, 12 members, could be any size, picking 12 here because it makes good movies, and articulate what proportion of that jury should represent each identity or intersectional identity. So for example, if you're again taking this online toxicity space where there's been lots of activity in my side of the world, you might define a jury that's going to highly represent groups who are commonly targets of harassment. Women, black individuals, black women especially. So this changes the sort of semantics of these models when you do this. When the model says, here's what we predict, it might mean something more like this. For this jury with the following composition, this jury would vote it to be toxic. And this is, I think, important because what we stop doing is instead of trying to smush people together into some single label, what we're trying to do now is say, well, actually, we ought to be modeling individuals, individual annotators or individual people within the instead of the training set. So what the model starts to do is actually make predictions for each juror, aggregating those to produce a final outcome. So it might look something like this, where you're specifying different kinds of identities or characteristics that you might care about making the decisions in what proportion. You might have some set of, say here, liberal jurors, another set of jurors who have high school diplomas and are parents. You assign them a certain number of seats. This populates sort of your jury space. Here's a very small one. And then what we might think about doing is actually, for each decision, sampling those annotators out of the larger annotation pool based on the people who match those criteria. We're going to sample them randomly. We're going to use them to populate the jury. We're going to predict what each of them would say, and we're going to make a decision. So this might be, in this case, not toxic, or if it's a regression outcome, we might actually predict the regression. Now, one thing you can't do in real life, but we can do because this is all happening through an algorithm, is sample many, many different juries that all match these criteria and be able to articulate, what does this all look like? Well, not every jury would agree. So what we start to do is be able to visualize what different juries might think, even though they all match the same criteria. We have to return some response, so here we're going to return what the median jury says. This has all sorts of downstream implications, like for interpretability, right? You get interactive sense-making about the nature of the disagreement. You know, there's not just one person who has to stand in for an entire group. You get to start to understand what's the distribution of all the people, and where do the jurors who were selected for this decision come from within this group on their feelings on the matter. Now, this starts to ask all sorts of interesting questions about, I sort of hand-waved, it predicts everyone's response. Traditionally, again, we have no notion of who is giving the response in these AI models. But if we start to integrate those kinds of things, it means that we can draw on lessons that we've learned over many years from, for example, the recommender systems literature, because you start to see things like this. In a typical data set, you have a set of people who you've sampled. They've labeled just some of the things, but not everything. It's very sparse. You have a bunch of other people who you didn't sample right now, but you might. And then you're given characteristics about each individual. And you might want to, and you don't know what's going to show up. You have to make predictions about comments that you've never seen before. This allows us to start to draw on what's called, in this case, a cross and deep network. This is something drawn from the recommender systems literature, the kinds of things that power Netflix. What movie do you want to see? Well, learn something not just about movies, but also about people. What do you like? So we're starting to model what are sort of groups of people, what are the patterns in what people think, and and the relationships between the people and the topics. Now, I'm pitching a metaphor here, something sort of a jury as a metaphor for how AI might make decisions in societally contested spaces. And you might have a question. You might have many questions. Amongst those questions might be, can jurors be biased? Absolutely. I do not say that jurors cannot be biased, but I think that's the wrong question. Because if you give me a choice between trying to de-bias a model post hoc after all of this bias has already been baked into it, or selecting and training the appropriate folks upstream, I am always going to pick the upstream solution. It's much easier to avoid throwing sewage into the water than trying to clean up the sewage later. You might also ask, well, okay, you're making, someone's now making an explicit decision about who the jury ought to be. Who gets to decide that, right? Well, one thing we could think about is that this is actually an opportunity for contestation, right? We can actually debate this. My point of view on this would be this is something that's much more readily debatable than like a precision recall curve trade-off. I'd also point out, by the way, that all the data sets we're already training on already have a jury. They're just hidden, they're implicit, right? They're sort of swallowed up by this majority vote. And actually, we can sort of backwards solve for this using the approach that I was describing. This large toxicity data set I was just gesticulating toward is actually 74% white or so. So it looks a lot like me. So I think it's much better to actually just make this transparent where stakeholders can deliberate over it, right? We should force ourselves to make those kinds of decisions out loud. So we can start to go to people and say, what happens when we put this in front of folks? We get moderators on large sites, Discord, Reddit. We ask them to author these juries. We measure things like who's represented in the juries for the decisions that are being made on their own platforms, or who ought to be. And again, I'll remind you that the baseline here is looks a lot like me. And we also ask them, does jury learning change the classification outcomes? Okay, so maybe we change the jury, but does this actually change the behavior of the classifier? Well, on the representation side, we see that there are massive swings in the representation of the folks that are included on these juries, largely by reducing the representation. You can see in the red lines here, the representation in the background data set here. This is where I'm getting the 74% white number. And the blue bars are the ones that are sort of in the participants' juries that they selected. So you can see increases in many of the groups, largely by reducing the representation of white jurors. This changes the downstream outcomes. About 14% of the classifications that are produced from this are different than those of the state-of-the-art classifier. And we can say, well, what's likely to flip? It's often the things that are highly contested. Comments around racism, death and suicide, LGBTQ plus issues, mental illness and policing, and so on. These are things that are, who you ask really matters. And I would argue that these are seen by the users of these platforms as effective policy. Now, there's many things that don't flip, things that people agree are clear of the line, like positive things, thank yous, happiness, or things that everyone essentially seems to agree ought not to be included. Human trafficking, various racial epithets. There's no disagreement there. It's really the things that this model is changing has to do with the stuff that's right in this societally contested zone. So as we talk about AI, I want to encourage us to talk also about ground truth. I want to call out to my graduate students who led this work. Can you wave? You're all in the room, I think. Mitchell, June, Michelle. Go talk to them. They're really excellent, as well as my colleagues who collaborated with me on this work. So thank you for the invitation.
All right, great. Thanks, Michael. We now have time for a conversation among the panel as well as questions from the audience. If you step up to the mic, remember to introduce yourself, and also to the folks out online, we see you. Okay, so those are very different views, I think, of this topic, all very interesting. I had a really basic question, I think, starting at Niloufar, and I think Michael as well, and maybe even, I think, comes into something Melissa talked about, is this idea of being able to design the models for these systems at the same time the interfaces and trying to separate them, which we might want to try in some ideal design process, doesn't really work. Are there real barriers to that in terms of the tooling to do it or design methodologies? And what does that mean, at least for a research community, of like how to make that happen for industrial practitioners?
Yeah, I think there is quite a bit of a difference, because when you think about a lot of the conditions that these methodologies were developed in and were really brought forward, the technology was very different. So I think the methodologies need to be developed more or differently as well. And there's this really great paper that I can share later because I've forgotten what the title was, but it was about sort of what makes human AI interaction really difficult to design for. And they talk about these really interesting things around, need finding that I mentioned. We often think about what do people need from the technology, but without knowing also what the technology could potentially do, it's really hard to do that need finding. And then, prototyping is really difficult, and so we need better tools to prototype. Testing, evaluation, I think is going to be really, really important. And thinking about evaluation as the way that it's commonly thought of in AI, which Michael also talked about, which I think is going to be really important, is sort of like testing against the ground truth versus thinking about in a real world environment. And in that condition, I'm really inspired by the physicians who we've been collaborating with, the way that they think about it, the way they think about RCTs as sort of being the gold standard, and you didn't do anything if you didn't do an RCT. And I think there's a lot to learn from other fields who have had similar issues, and thinking about how do we take each of these pieces of the methodologies and develop them to be able to work better with these new kinds of technologies.
Any other comments?
So my tepid to hot take is that I think we're rapidly hitting the limits of what you can really do by taking a model as given and trying to wrap an interaction around it. I think that this has sort of been our modus operandi for such a long time in HCI. They're like, well, okay, we've got like a VR system. Let's like think about what interactions might happen around it. But I think especially in the case of artificial intelligence, it's really holding us back because it's making us beholden to the assumptions of the models in a way that's often harmful. And harmful could just be it's a bad product, or it could be actively harmful. And it creates, I think Jody was gesticulating toward this morning, like creates this really tough space that we have to become experts at everything, and this is yet another thing we have to become experts in order to actually do a good job of designing. But I think that if we're going to see truly transformative opportunities, they're going to have to start from that assumption of like, actually, as Mosa was demonstrating, how do we get in at the modeling stage rather than later?
So I'm wondering, is that true for some of the bigger trends? Right now, we see a lot of people, including your own students, my students, poking around at foundation models without any understanding of what's going on inside the model. Is that different because of these foundation models and we're going to build on top of that? Or is that foundation going to crack if we want to get the kind of control that you're talking about?
I'm going to answer the other one and then let you do foundation models. Because I think what I observed, the data science team that I observed had data scientists who were really good at modeling, and then they had a really talented UI person. And I think the process that they used was so iterative, and they assumed that they were modeling for interaction, and they assumed that they were modeling for their users. So they were able to sort of in context prototype and iterate and design in collaboration with their users. And so they sort of like as they were going, they changed the UI because they saw that the users thought about it a certain way. They saw that the users were much more iterative with an adjacent occupation, the planners. So they sort of made it more of a like iterative way that the users interacted with the UI. So it's just sort of, I think that illustration is like a +1 on the model. The data scientists have to be modeling for the user, like what's happening in the user's actual expertise. And they have to have space to really help the users transform the way that they're thinking as well. Foundation models I didn't study, so go ahead.
Turns out we didn't have an undergraduate course in them when you were.
Yeah, that's right.
I think we mistake sometimes the legitimately impressive power and advances of these with what it would take to cross a chasm of becoming useful. I think I agree with you that we've seen a huge promulgation of applications building on top of GPT-3 or DALL-E or Stable Diffusion. Are we seeing things that people are picking up immediately and are changing their process? I'm inclined to agree a bit with Manish here, where I think that like prospect theory rears its head. People are risk averse. If there's a 5% chance this thing's going to do something silly and embarrass me, I'd rather just do it myself. And looking back at at Ben's talk this morning, just looking at being able to see the multiple options, et cetera, I feel like there are ways to soften that blow. But I think that people are savvy. If if there's a 1 in 20 chance that this is going to be a catastrophic error, like in the space of these medical domains you're talking about, I'm not going to chance that.
Mm-hmm. I was wondering about, again, about how much we understand about the models and Manish's black box argument. In your translation example, it seemed to me like, doesn't the underlying AI system have some confidence value or some metric of how good it is? And if I had just revealed that, might the doctor go, oh, that's a 70% one. Maybe I need to call the person on the phone rather than trust that. Do we have any idea of how the technology there is actually working and why that's not the UI?
I think that's a really interesting question and goes a lot to what Salima was saying about the quality estimation. For translation, quality estimation is about as hard as translation itself.
Okay.
So we don't really have good metrics. But I think what's really interesting in some of the work that we're doing, going back to the evaluation question, is that we are testing. So in, say, a study we're running right now where physicians come in, we bring in an actor to pretend they're a patient, and they're communicating with each other. They're trying to do a diagnosis, and we're going to see, like, if you just show them the translation versus if you show them translation plus any of the quality estimation models, the best ones, does it make a difference? And we don't have the results yet, but my hunch is that no, it doesn't, because the quality estimation doesn't really give you the information that you need, which is, I think, really important in thinking about then what sort of quality estimations do we need and what could actually be useful. And I think there's a big disconnect there between a lot of these quality estimation models were built to help in the training of the translation models so that you can take a lot of data, translate it and see and better your translation tool. But I think there's a big disconnect to what is actually useful, which is, I think, something that the medical domain has been really interesting for me in learning that there's a lot of pragmatism that I think we could use from. So even the study that I showed, which was one of the motivators of us studying this question, that 8% of the translations are wrong, it's actually published in a medical journal, and it's published as a positive thing. So it's like, look how great this is. It works 92% of the time. We should all be using this. And when you bring it to a group of people who are building these systems, it looks like a huge failure. So I think that's something that's really important for us to know. What are the risks? What are the harms? How do we evaluate these things? How do we evaluate them in the context of use and in ways that are actually useful?
I actually, if I was going to identify some themes that I've already seen today, this idea of the metrics of evaluation has come up, explicitly in Salima's talk as the main focus. But like in every answer, you have it, Michael, you have it. And I'm really curious, sometimes those metrics are maybe made to be easy for AI people to check how well their model's doing and have these online competitions that have had a success in pushing the field forward. But it seems like they don't actually match the values of use or humans, yet those values to get them into metrics seem hard. So I'm wondering what's the work that needs to go there to kind of close the gap between the kind of metrics that AI folks want to use for their reasons, but fall down when meeting the reasons that we need it for human consumption. Ideas there? How do we close that gap?
I mean, I think my context was pretty specific because it was a for-profit business, and the data scientists were accountable for getting their users to adopt it and use it, and the users were only willing to use it if it actually helped them do their jobs better. So in that case, the impetus was on the data scientists who worked really hard to do this, to make their product useful for the business users. So the business users were always interested in the same business metrics they had been in, and then the data scientists figured out a UI that sort of put for example, like a machine learning client segmentation kind of behind the scenes. So I don't know. So it was in the context, like the business users metrics was already kind of what was driving it, which I think would be different for academics.
Any other? Okay.
Well, I mean, I'll just say, and put yourself in the shoes of a PhD student. It's an hour before the iClear or NeurIPS deadline or something like that. How do you, what can you evaluate in that time? Right? I think that there's a very practical constraint that they often operate under, which, in HCI, this is why we end up getting IRB approval, months potentially at this point before the deadline and collecting that. We're not operating on that time scale. Yeah. And I don't think that we as HCI people have yet put forward a viable alternative. And I don't know, that may be on us. I don't know. If I had an idea of how to put that forward, I'd be doing it, but I don't yet.
I mean, I would say in some of those communities, there were workshops or organizations like NIST that were involved in some of the earlier benchmarks that helped push the field, but maybe it's time for the HCI people to call, have those workshops and say, hey, work together to do it or something. I don't know. We have a lot of people who are waiting at the mic, so why don't we go, please identify yourself and then ask your question.
Sure. Hi, I'm Meredith Ringgold Morris from Google Research. So I love the jury learning work, but seeing the talk makes me worried that the field of AI is becoming like the TSA. So you think about the TSA at the airport, and they're just super reactive, right? It's like, okay, someone put a bomb in their shoe, so now everyone has to take their shoes off forever. But they're not really predicting in advance what the threats are in a coherent way. And I see that a little bit as an example in the jury learning work where, of course, we do want to see more demographics represented in AI data and decisions, but how do we decide a priori what those should be versus just being reactive to problems we see? So, gender and ethnicity are a low-hanging fruit to add, but there's a million other data demographics that could be on our juries. And how do we anticipate what those are in advance instead of waiting for the next AI disaster where we're like, oh, we forgot about people with disabilities, or oh, we forgot about 42-year-old Midwestern women with 4 children who like to wear Nike shoes. So I want to hear how AI cannot be the TSA.
I was very close to being described by that last one. I think that increasingly computer science is political science, or ought to be. There's much that we could and should be drawing from. This is why it's amazing to be a place like this where we have such an amazing political science department where I can collaborate and these things. It's these questions of governance are not new. It's not like online platforms are the first ones to ever have to deal with these. I do think that we're very late to the game of realizing what to do about it. The paper that my colleagues and I keep looking for but have never seen, but seems to be sort of informally empirically true, is that most online governance does get set in reaction to disasters. You create some online group, things are going great, and then there's like a huge flare up, and then you create procedures around that. And so we are very reactionary. But I agree that there's a lot of knowledge that's been generated by the social sciences, by folks in accessibility and others that I can tell you all the ways in which teenagers are going to abuse this system. And yet every startup seems to repeat the same sort of litany of mistakes, sometimes after they've been bought for $44 billion. And it's a challenge. So I think that if we can put together something beyond checklists, because I think it's easy to ignore the checklists, but at least sort of what Howard Rheingold refers to as governance boot sectors, like have a good starting state for governance that every community can fall back onto. I think that's what I would argue is our first step.
Any other? Okay. Next question.
Bob Glushko, Berkeley Cognitive Science. I'm going to say, Melissa, thank you. That was the most positive story I've ever heard about data science. They actually learned together to do good things. It was just so wonderful. But it reminded me of 2 things. One is, we used to talk about expert systems. Has that word disappeared from the vocabulary? Expert systems? Remember that phrase? Because it reminded me that 40 years ago when I was at Bell Labs, my department built an expert system to help maintenance people predict faults in the physical plant. Like, when is this cable going to go bad? And we named it ACE, Automated Cable Expertise. And this is a shout out to Jody. The union refused to deploy it until we renamed it Apprentice to Cable Expert. Because they viewed the first title was the same, it was software did not change.
Yeah.
But changing the name of it meant they would say, this works with us and values our expertise versus descaling us. So I mean, that kind of labeling really does matter. But my real question is, what happened to the word expert systems? Is that gone? Does that date me as a 1980s guy to say it?
I mean, I feel like when I do my literature reviews, I read all about it. I don't think it's like currently that active in the current like things that I'm reviewing, but I think it's so relevant. So I'm glad you said that. I think it's fantastic literature, and it's quite relevant. I mean, that's cool.
Yeah, I mean, maybe we could hear from Ed Feigenbaum. I think he was here earlier, but expert systems are definitely around. It's just what's changed is how we implement them. We're still saying we're going to have this augmentation of humans, an expert system that's going to, give you advice and you choose, right? It's the metaphor is still similar to what we have.
Yeah, and I have to say, to give credit to, I think the data scientists who I studied were really like exceptionally good at human-centered design, and the company that I was at just had a very kind of a great data culture around it. So I can't take credit for the positivity. It just.
But I was curious about that because they seem to have this really nice, setup of there's the data scientists and they're working closely with the employee, with the knowledge worker, as you referred, and it made me wonder. Some ideas of the future of computing is, well, everyone's going to have that. You got to take that data science skill, and they would do it themselves. Could you see that knowledge worker doing that work, or do you really see that they needed this kind of expert to work with them? Like, what's the future of how that role will be?
Yeah, it's a great question. I mean, honestly, I don't think that they wanted to. The knowledge workers were there because they loved fashion, and that was their identity. They wanted to do really good fashion. And I think that they obviously self-selected into that retail tech company. They were there because they recognized that the company was trying to transform disrupt fashion through data. So the people who were there had selected there, but they truly want their knowledge work that they wanted to do was to do fashion. But I think that their identities did shift over time. It did take time for them to start to recognize themselves as experts who would make use of an algorithmic system. And they, at first they just were it was hard for them to think like that. It took a major change in the way that they thought about things and in their identity to recognize that it helped them do what they wanted to do better. They would be better fashion buyers if they used the algorithm. So I think that was the change that they wanted. So I would predict more of a collaboration, more of a cross-functional collaboration going forward.
Great. Another question from the mic
Just
here.
a quick one. So Michael, your thoughts sparked something that's deeper in AI these days. Even a natural language parser that's built using statistical neural parsing, it's entertaining a whole bunch of hypotheses about meanings of sentences and questions such as we might ask Google speakers. And I wonder, how deep is this problem that we are, in the end, surfacing one parse or one way of interpreting the question and answering that, and the other parses are suppressed deep. And whether the kind of observations you're making about sort of segments and contexts that exist within the sources of labels and data, that also exists post that, so that we really should be aiming towards quantum computing or some approximation thereof to keep entertaining these multiple hypotheses and contexts till we need to converge.
Well, until we get quantum users. So I'm going to be very interested to hear Niloufar's take on this, because I think in the medical context, it changes the calculus substantially. But it's not immediately clear to me that a top-end list, as sort of tends to get returned by these, is necessarily the right way, the right representation for how people should think through these alternative paths. Now, this has been an issue in the information retrieval literature since nearly the beginning of time for information retrieval. If I search for Java, do I want the coffee or the programming language, right? The classic question. And I can only give you one set of search results, right? So I think that this sort of, as you would put it, superpositioning over multiple possible interpretations or points of view, if you're in an application domain where that matters, I think you ought to directly do this. There's, again, classic HCI work on what's called design galleries, where the entire intent is to show you a wide range of different outcomes, depending on sort of what you think might matter to you. But if I'm not in an application space where, I'm trying to design a poster or something like this, that might not be the right way to convey all the alternatives to me. So having given her enough time to maybe vamp for an actually intelligent response, I'll give this to Niloufar.
I think that's actually one of the things that we've been thinking about is that the way that we're thinking about it is we want to find sentences that have the same clinical intent. And that's oftentimes different from having the same meaning, or there might be multiple different cases. So we've actually been thinking about what would it look like to show you multiple different things if we're not so sure about what you mean, or show you options. And I think that could actually be really helpful for the physicians because they have a lot of context that they're holding in their heads. They have a lot of potential alternatives or clinical intentions that they're trying to communicate. So I think that could actually be a helpful way to think about it in a medical domain, both like in a diagnosis task or in a communication task.
I mean, it appears that even current conversational agents have that context sensitivity where occasionally, instead of answering a question, it will ask a clarifying question.
Yeah.
Did you mean this or did you mean that? And building upon that idea more and then sort of keeping many possibilities around it seems like the right way. Thanks.
Let's go over to this mic, and please introduce yourself first.
Yeah, Anoop, and really getting interested in this area. So a big question that I keep ruminating over is, well, as they say, right, in statistics is you can have lies, damn lies, and then statistics. That's what someone said. Now with AI and models that are black boxes, as Manish said, it's like we don't even know, or we can't even investigate and verify the lies that data scientists could probe into. So instead of like ground truth and ground lies, what are the thoughts about ground education, grassroots level education, before this becomes a fire hose, or it has already become a fire hose of applications, and to make it accessible actually, because there are benefits to all this. But you don't want, you want AI to help you make decisions, but you want to take the judgment yourself. You want to make the judgment yourself. So what are your thoughts on this rambling of a question?
Michael.
They want me to ramble. Okay. Ben showed this morning a picture of a terminal that investors use, right? This is what we'd refer to as an expert user interface. You don't just throw someone in front of that, right? They get training. They know how to interrogate it, how to manipulate it. I think that when there are some contexts in which what you want is an expert user interface, the command line terminal being another example. Photoshop. Many of these tools are not designed for sort of just walk up, click, and wow, now there's a picture of Manish looking young and really vibrant and so on. I think what part of Manish was complaining about was that it didn't make him look young and vibrant. No, was that it was trying to. He didn't have controls, right? There was no expert user interface here, right? And I think where we sometimes get into trouble is that we can't even succeed at that. It's hard to wrap, Windows icons, mouse pointers, WIMP interfaces around something that's even where we have complete control. But now we're in a situation where we don't have complete control, and we're trying to create a very simplified user interface on top of it, and we're just building on top of sloppy foundations a little bit. Now it's not clear, as Manish pointed out, that we currently know how to do any better. But I think that if in those situations where it's sort of like end user applications, it's not even clear to me how we identify the lies, the damn lies, and the statistics, or help someone do it. There's great work in the School of Education looking at misinformation identification, and the basic answer is like, don't go deep, go broad. Look at who said this and who else said what. And I feel like we don't have those similar kinds of techniques. I couldn't tell a designer do this to overcome that issue.
Right, but you do emphasize the need for education, and basically before it gets out or has started getting out to the people, and like we missed the boat on social networks and information and verifying that information, but there's an opportunity here to catch things before, instead of electricity, it becomes the fire, as it was said this morning.
I think the question is where you want to add friction in the system. Where do you intentionally want to make things harder or slower in order to guarantee sort of the cognitive amplification and not the wildfire, right? There are times where you need to slow down.
Okay.
Thank you.
Thanks.
Let's go over to this side of the room.
Thank you. This, going back to Genevieve's
Can you
comment.
say your name again?
Oh, sorry, Laura Wilson. Coming back to Genevieve's comment this morning about getting to the productive discomfort. And Melissa, I'm wondering about were you just observing or were you a participant in some guide rules? And where they started, within a company culture, what the profit is, there's a lot of common ground to start those two teams. But they were speaking different languages. So as the conferences had so many all these different discussions coming back to how does we address this translation between different disciplines, I'd love to hear how that groundwork might be applied and all these great other examples that we're hearing.
Yeah, that talk was so great this morning. I really appreciated it. So thanks for bringing it up and giving me a chance to talk about it. So you called out things that I would say. So company culture, they were already on all of the same systems. People had self-selected to be in that company together. So a lot of the work had already been done, but it was still very hard for them to translate across their. It seemed like it ended up just being like their occupational mental models. So what the data scientists cared about so much was, standardization, measurement, modeling, formalization, and what the fashion buyers cared about was just solving the problems that they needed to solve. So the structure that allowed them to work together was really just a human-centered design, sort of like over time. And I think the data scientists' mental model was that they needed to understand the mental model of their users. So their prototype sessions would be in front of the user interface, and they would just be talking about it and gesturing to it and sort of, having that boundary object where they were able to, that's what helped them kind of translate across it. The data scientists were also willing to change a lot of things even after they had sort of realized that it was going to be a constrained optimization. Like they were willing to change so many things in the UI and change so many things in the algorithmic interface so that the users would be able to use it in the way that felt better to them. So having spaces, the prototyping spaces, I think was where most of the translation work happened between the two occupations. And I mean, it took a long time. It was like a year process before, they had the going system, and then it was like 6 months before they had actualized business results. So it took a long time, I think, is the other answer. I don't know, any thoughts on translation or Michael?
Okay, let's go over here.
Hi, good afternoon. Carlos from UC Berkeley. I had a question for Michael on the practice of this juror selection that you were making to kind of have more inclusivity on the data processes. How, I understand that from a research perspective, this is something that you can maintain long term, and you can actually have as sort of a case study for inclusivity in more democratic decisions. But how practical and sustainable is this in a more commercial sector or in a more professional setting that's not research focused, where you want to make sure that you are having inclusive selection of the data that you're using to train your models, but you also need to have that time frame in mind, and you cannot cover all these different categories of people that you might be looking for. So how do you make that decision in a commercial side?
Two quick observations about that we saw through the project. One is because of the way that this model works. Now, if you don't have any people representing some group in your data set, you kind of got to go get them. But if you do anywhere, then it's immediate, right? There's no retraining needed. So the sort of cost, quote unquote, in that sense to the organization is very low. I think often, really all that's happening, like the mental trick of this project at some level is like getting people to ask aspirationally, who are we? Or who do we want here, right? And I think often you get more pro-social responses than when people don't stop and reflect on that. So often those folks are in the data sets already. In fact, everything I showed was essentially on top of a data set that already exists that we didn't publish, that other people collected. Like, this happens, but people just haven't been thinking about it correctly. The other sort of practical response I would give is that it turns out this actually produces like better performance as well. Again, turning back to Salima's comment earlier about what we measure matters. On something like comment toxicity classification, and you're trying to predict, and you have a state-of-the-art model that's trying to predict the aggregate label, the performance on that is lower than through the model that we use, because it turns out that knowing something about who's being asked to render the response gives you a lot of predictive power. So if you simply do it this way, you actually taste great, more less filling kind of response, where it turns out that if you do it this way, you're actually modeling the phenomenon better as well, and so your performance gets better. Now, I think there are power and structural issues that I'm not addressing here, which is within an industry context. Are there potential liability issues if we make explicit who our jury ought to be? Should we be forced to publish that? If we don't and we know who the jury is, can that be a cause for like a lawsuit and discovery? Sometimes there's this sort of legal maneuver of like we can not know intentionally. And that I don't have a direct response to, but I do think that there are many situations where there might or ought to be such a better answer.
Thank you.
Okay, I was just going to make a plug for the folks online. Ask questions, because Russ will call on you if it's a good one. Let's take one more over here before we go online. Jeff?
Hi, Jeff Bigham, Carnegie Mellon University. So really great panel, really great talks. I guess one question I had is, it seems like a theme today has been that the problems are more complicated than we thought, that a lot of the kind of manual, kind of intensive design work, understanding your users, and iteration turns out to be really important. Who would have thought? But I wonder, so is the right way to think about it that foundation models and some of these really amazing things, which people have pointed out are amazing many times today, is it that they sort of give us this false sense of efficacy, so they get us really close but not quite there? And if that's something like the truth, then what's really changed? So has something about the design process actually changed because of these advancements? Or is it pretty much the same, we're just rediscovering that because we got kind of tricked by how good these things kind of work out the box, even though they're not good enough?
Yes.
I would claim maybe those things are good to help us to actually prototype the things that we want to understand better, but maybe they won't be sufficient to ship the real product that's good enough for what we think are the metrics that we think are necessary for good human impact.
Yeah, I mean, one sort of mental game we can play here is like, we have these continuous changes in the performance of the measures. Where are the qualitative changes in user behavior, right? It's not continuous. I've talked too much, so I would like others to speak.
So I agree, actually, I would build on that. So I'm not a HCI researcher, so the framework that you're describing I might be getting wrong. The long tail of automation seems alive and well, is maybe what you're saying, yes. And I think what Michael's saying is the same thing that I observed, which is there was a lot of interaction, but there was this phase shift, which I think is what you're saying, right? When it finally got together and the computational power was it was staggering. It was I can't believe they could do that in a second, and it used to take them 6 months of manual labor to do it. So maybe long tail of automation, is that what you're saying, is alive and well, and you're saying the computational phase shift when it finally clicks together is pretty cool. So it feels like that Jeff is saying that we know that. Yeah, that's right. True.
I would also just caution, I feel like it's early days and it's pretty hard to make a conclusion whether it's going to work or not when we've only publicly seen a few of these models so far. Do we have a question?
So this is from Nupur Ravel, and it's for Melissa, although others may have comments. And it's, could you speak more to the intuition, gut aspect of the datafied worker? So I think the knowledge worker who became dataficated. That's my verb. A lot of value of experts and their immunity in the face of new tech lies in the uniqueness of their judgment and the bets that they make. So did they develop intuitions about the new tech that was mediating their work in the same way, and I'm adding this, in the same way that they had intuitions pre-existing about how to make bets in their informal theories of the actual domain? So did they use that trick again?
Yeah, oh, interesting. So that is a great question. Thank you for asking it. I think the intuition that the fashion buyers had at the start So it actually kind of reminded me of Moneyball. I think that's like a book and a movie that people are possibly familiar with. So where like baseball coaches would be like, this baseball player is gonna be really good, I just have a gut. And they would sort of miss a lot of different characteristics or metrics that would actually predict the team being successful. So I think that the fashion buyers were sort of similar. They would like see a pair of, like an item of clothing and be like, that's gonna be cool, but they weren't thinking about like the whole inventory. It's hard to model a whole inventory just with your mind. So it was that sort of, their intuition was really focused on items, not inventory, and the algorithm helped them do inventory in a way that was more systematic and measurable. So it was a very different sort of way of making decisions, intuition based on single versus systematic, like inventory, like a system of clothes almost. And then I think the second question, or like the actual question was, did they develop intuition around the technology? I think what changed the more that they used the technology is they were more willing to take the recommendation. The recommendations tended to focus them more on like known performers and would have them kind of buy in more on known performers. Over time, they were willing to follow the recommendations, and they started to recognize that that would buy them some room to experiment and some room to play around with. So I think that they developed expertise in using it strategically to do the stuff they wanted to do. So follow the recommendation on the easy stuff, experiment on the stuff that was like cooler fashion for them. So if you want to, so I think that was like expertise with the technology. I don't know if I would call it intuition per se.
Great.
I had just quick clarification. Is the data that they're looking at only their own sales data, or are they looking across the industry, and does that lead to kind of even more of this fast follow cycle of following trends really quickly?
Yeah, it was their own historical data.
Just their own data.
Sales data,
Okay.
yeah. I mean, their data science team was very research R&D focused, so they were doing cool stuff with like pulling computer vision of like Fashion Week and stuff like that. But the one that I was looking at was just the historical data.
Okay, we had another question over here.
On intuition. And sometimes it can actually be worse having that intuition, because a lot of the physicians that we saw, and even the patients, relied a lot more, I think, on Google Translate than they should have. And I think a lot of that is because of their past experiences, which might have been while traveling or like translating a menu that worked pretty well. And so people develop this intuition that this works pretty well, whereas when you look at the data, it actually really works. And so I think that, and we found one case where there were some recommendations for how to use Google Translate in a medical setting, and it had recommendations like use the back translation to check. And there's been some research on it with mixed results, sometimes showing the back translation is even worse, because what the model misunderstands, it then misunderstands again in the back translation. And so you get the correct thing back, but the other thing was just completely rubbish and had nothing to do with the meaning. And so I think that intuition can be a little bit of a dangerous thing. And it's important, I think someone talked about education, I think testing, frameworks, institutions that can, do these larger scale evaluations and then teach people how you should be using this, how you should be evaluating it, when and how to use it, and where the liability lies, I think is going to be really important moving forward.
And you said that revealing the accuracy maybe not be the right thing, but we probably do actually know, like the numbers you showed, the accuracy between different pairs of languages.
Yeah.
So, those people might get the wrong intuition because they translated English to French when they went to Paris.
Exactly.
And it seemed to work good, but they had never really tried Mandarin
Exactly.
before.
So there's a big difference across high resource and low resource languages, and also languages that are further apart. English, Spanish works pretty well, but then the interface doesn't show you any difference. So it's still the exact same interface of this text is the equivalent of this text. Whereas, for instance, in Farsi, we were just testing a data set of conversations that a physician had had with the patients. And the Farsi was just rubbish. It just didn't mean anything. And some of the times the back translation actually was the exact same thing. But it just wasn't working in the Farsi. But again, the interface will show you no difference. And I think that's a big problem.
Okay. So I know you've been waiting a while. Introduce yourself, please.
Hi, my name's Betty Xiong. So my question is, in the absence of a consensus, for example, if there's no ground truth, like in medicine, there's a lack of gold standard in many cases where clinicians don't even agree with each other. How do we establish good metrics around this or a proxy thereof?
So there's a really interesting paper out of Google AI Research. Carrie Kay was the lead author, where they looked at onboarding of a diagnosis tool with physicians. And so they brought physicians in, they showed them this diagnosis tool. I think it was for cancer diagnosis from images, and then they asked them, so what questions do you have if you were going to actually use this? And one of the most salient questions that all the physicians asked was, the person who coded this data, where did they go to school? And I thought that was just fascinating. I think it has a lot to do with how physicians actually think in a context where they have to make these decisions, they have to be pragmatic. You know, yes, I know that this tool has errors. Almost every tool that I use has errors. And you know, I rely a lot on my colleagues. If they have doubts about something, they will assemble you know, a group of colleagues. They care a lot about where someone went to school. And so I think there's a lot to think about there in terms of in other kinds of settings where we have these uncertainties, but also really, really high stakes. What are things that we can learn from how we've been doing it so far that may be translatable?
We had a really interesting thing happen after we published this work, where a researcher at UC San Francisco, who's medical researcher, reached out to us and said, "Well, no, I don't care about like figuring out what the optimal jury is of like different kinds of medical specialties, but what I do want to be able to do is actually sort of put on different tinted glasses and see what like a radiologist would see when they look at this image versus what an oncologist would see when they look at this image, and so on." So I think that there are, you know, again, human augmentation answers here that may be appropriate.
Okay, we have time for one more question. Professor Paredes.
Hi, my name is Pablo Paredes, University of Maryland. So I'm curious about how much bias it's actually tolerable for humans to operate in real life, because we learn to be biased such that we don't have to make so many decisions on an everyday basis. That's why we're like, you know, our emotions are limited in how we describe them, our feelings are limited. Is there a point where we show people too much information, too many choices, and then they eventually, this paradigm of choice breaks it and say, I just want to be indoctrinated, right? You know, help me up, because, you know, it's too much for me to decide, and I just need somebody to tell me what to do.
Yes.
Could it backfire? Yeah.
So there was an article that we just published that was looking at, it was kind of a counterintuitive finding about explainable AI. In this case, it was, again, in fashion allocators were being shown a lot of information. And when they were given a lot of information, the kind that like an explainable AI person would say they should be given, they started to override their own previous judgments. They would like make judgments that were different. And when they learned, the thing that eventually in this setting sort of helped with that problem is when they saw that their peers were involved in the development of the system, then they started just taking the recommendation versus needing to like sort of see all of the information. I think you're asking a different question, just people looked at me, so I was like giving you, that's in fashion. I think you're talking about social bias. So this was an instance where like too much information was making people make bad fashion allocation, bad decisions, like just things that they themselves would not have picked previously. So there's an example that bought you time to talk about misinformation.
If I could interject, though, in medicine where I work, there are systems that want to explain, want to be interactive, and the doctors who have 12 minutes to see the patients say, just give me the answer. And when I want to learn for continuing medical education, you can explain it to me there when I'm getting credit for my CME. So it's true, and that's a real, they have very little patience when they're in the trenches. And so time and resource urgency can change people's reaction to these systems.
I think it just depends on what the situation is. It's design, and it's going to depend on whether that task needs that control or not. And you're right, there isn't one answer.
Yeah, I mean, some blissful ignorance goes a long way too sometimes.
Okay. So anyways, with that, I want to thank the panelists for a great conversation.